Now we look at stem plots. Most of the time they're called stem and leaf plots. It's another graphical display for showing every piece of data. Notice it does say it's for small data sets because we are showing every single piece of data on this picture, and doing it with a set of 1,000 values would be very, very inefficient. So how to make our stem plot? We separate each observation into a stem and a leaf. The leaf is the final digit of our number. The stem is all but the final digit. We write all the possible stems from smallest to largest in a vertical column and draw a vertical line to the right. Then we write each leaf in the row to the right of its stem, and we arrange the leaves in increasing order. We should also provide a key that explains in context what the stems and leaves represent. So let's look at an example. We have 20 female AP Stat students answering the question, how many pairs of shoes do we have? And I mean, these girls are crazy. They got 50 pairs of shoes. That's insane. So here's our stems. The 1 stands for everything in the tens. The 2 stands for all the 20s, the 3 the 30s, the 4 the 40s, and the 5 the 50s. We then add the leaves. So we go through here, 50, I'm going to put a 0. 26, I put a 6 right here. 26, I put another 6. 31 is next, so I go to the 30s row and I put a 1. 57. 19. And I'm going to go through my list and list out all of those leaves. And then I put them in order. If you can go from the stems directly to the ordered leaves, awesome, do it. But if you need to list them out and then arrange them, that's fine too. But notice there's a number for every single data value. If we have 20 people in our sample, we have 20 leaves over here. And our key looks like this. For line 9 represents a student who reported having 49 pairs of shoes. This is essential. It's something you must do. Sometimes when we have more data, or when we have data that's bunched up highly, if we look here, we see a whole bunch of data piled right there in the 10s and 20s. Sometimes it's useful to split the stems. And if we ever are using 2 distributions that look at the same variable, for instance, men and women and the number of shoes they have, we can use a back-to-back stem plot. So here we have our female data, and now we have male data too. So 20 females, 20 males. Our split stems look like this. We have 2 rows for the 0s, 2 rows for the 10s, 2 rows for the 20s, 2 rows for the 30s. And to explain this, let's look at the 20s. This first 20s row will have the first half of the 20s. So 20, 21, 22, 23, 24. 25 would go into this row up until 29. So putting our males to the right, we label the top, says these are the male numbers. Then off the left of these stems, we can list the females. So notice that we'll look at the females here, 24, 23, 23, 22, and then 26, 26. Or in the males, 4, and then the next one is 5, so it goes in the second zeros row. A stem of 0 is essential for 1-digit numbers. And of course, we don't want to forget the key. We'll get into histograms in the next video.